Hello, this is Mrs. Poland. This is lesson 7.03 in Algebra 2, and in this video we are going to go over the skill signs of trig functions. So before we begin, I just want to review a concept we discussed earlier in class. When we're in quadrant 1, a point can be represented as positive x, positive y. When we're in quadrant 2, a point can be represented as negative x, comma, positive y. When we're in quadrant 3, a point can be represented as negative x, negative y. And when we're in quadrant 4, our point can be represented as x, comma, negative y. We also need to recall the fact that if an angle is drawn in standard position, the y-coordinate represents the sine of the angle, and the x-coordinate represents the cosine of the angle. We also know that tan of theta is equal to y over x, which is the same thing as sine of theta over cosine of theta. For questions 7 through 9, we're asked to find the quadrant the terminal side of an angle lies when the following statements are true. We know that cosine of theta is less than 0. That means it's negative. And we're also told that the tan of the angle, that ratio is less than 0. So that means it's negative as well. We can determine our answer in a couple of ways. The first method is more conceptual. We know that cosine can be represented by the x-coordinate, and since cosine is less than 0, we can represent it by negative x. We also know that tan is negative, and tan can be represented as y over x. But since x is negative from cosine of theta is less than 0, we can write tan of theta as y divided by negative x, which is a negative value, so we know that works out. Therefore, this point can be represented by negative x, comma y, and that point is located in quadrant 2. So that's the first method. So now let's take a look at another method, and maybe I'll do it in a different color so not to confuse. The second method uses a check-off box. So if you recall earlier today, maybe I'll do this I should do it in something other than blue. Maybe I'll do it in this pink color. That all the functions, that means sine, cosine, and tangent, are all positive in quadrant 1. We know that in quadrant 2, only sine is positive. That means cosine and tangent are negative. We know in quadrant 4, only tan is positive, and we know in quadrant 2, only tan is positive, and quadrant 4, only cosine is positive. So all students take calculus is one way of remembering this an acronym to help us recall when the functions, which functions are positive in which quadrants. So how does that help us in this problem? So we can do all students take calculus. Again, that's where the functions are positive, and do a checkoff list. So we know that cosine of theta is less than 0. That means it's negative. We know cosine's positive in A and C, all and C for cosine. Therefore, it's negative in quadrant 2 and 3. We want to find where tan is less than 0. Well, we know tan is positive in A and T, therefore it's negative in S and C. Where the double check mark is where the quadrant is, where the angle lies, so that's quadrant 2. Let's do the same, both techniques on problem number 8. So I'm going to get my calculator out. I'm going to put a line down to divide. Not my calculator, my marker. Okay, so method 1. We know tan is positive. and we know sine is also positive. Well, sine represents y, so I can express sine of theta as positive y. I know tan could be written as y over x. Y is positive, therefore x has to be positive as well, since y divided by x, which is tan, has to be greater than 0 or positive. Therefore, Therefore, I can represent a point that meets both conditions as x comma y, and that angle therefore is in quadrant 1. Now let's do the second method, and I'll try to do that in a different color. Maybe I'll do it in this green. So now let's use that other technique. So I make a little x and y axes. All students take calculus, and I'm going to do a checkoff box. I know tan is greater than 0, meaning it's positive. When we know all the functions are positive in A, and tan is also positive in T, in 3. Sine of theta is greater than 0, meaning it's positive. We know it's positive in 1 and also positive in 2. Therefore, where does the double check mark appear? In 1. So again, that's another way of getting the same answer. The last problem that was in the notes is a duplicate. So I'm going to change it slightly, so therefore I can show you another example. And so instead of saying for 9, tan is greater than 0, let's change that to less than. So let's do method 1 first. I don't know which one you prefer yet. You'll tell me tomorrow. And for method 1, we know that tan is less than 0. That means it's negative. And we know sine of theta is greater than 0. That means sine, which is y, is positive. Tan is y divided by x. Since tan is less than 0 and y is positive, and the quotient obviously is negative, that means x has to be negative. So we can represent, this is different. Negative x comma y, that means it's in 2. Now let's use the second method. That's where we do all students take calculus and we do a checkoff. So we know that tan is less than 0. Well, tan is positive in A and T, therefore it's negative in S and C. We know sine of theta is greater than 0. Well, we know sine's positive in 1 and 2, therefore I know my angle has to lie in 2. I hope this video helps. See you tomorrow.